Hello friends, this is my next lecture where I'm going to explain to you with some detail how to change the variables to evaluate a double integral. I've already explained in one of my earlier lectures that a change of variable is necessary whenever the original variables do not favor the integration. It could be quite possible that the limits of integration will not allow you to integrate, or it could also be quite possible that the function may be a nasty function. So we have to probably tame both of them, the function as well as the limits. Therefore, a change in the domain may become necessary. So whenever we want to change the original variables to new variables, we need a transformation equation. Set of transformation equations. So when does this situation of changing the variables arise? Now for this, I would like to show you a few examples through which you can get an insight about how one senses that a change of domain is necessary. Now look at this problem, the double integral of e power x minus y by x plus y dA. Now let us not look at the other parts, but only concentrate on the function. E power x minus y by x plus y is generally considered a unfriendly type of function, even if the region is simple. So this region, for those students who have basics of straight line geometry, is a triangle, a right triangle in the first quadrant. So the region is simple, but the function is a bit unfriendly. So this can be a reason why we think of changing the variables. That means the variables x and y may be transformed to new variables u and v by a smart substitution. We'll think about that shortly. How to design a transformation will also be explained. This is another problem. In this case, the function is simple, but the region is not that simple. You know, y is equal to x and y is equal to 3x are straight lines passing through the origin with slopes 1 and 3, and then cut off by the straight line x plus y is equal to 4. If you can imagine in mind or take a pen and paper quickly, you will find that this triangle is in very bad orientation. Therefore, we can also think of a change of variables in these types of problems. So the first one, function is difficult, region simple. Second case, function is simple, region complicated. We are not able to make out anything from this problem. But one thing can be said, look at that function, 1 by square root of xy minus y squared is generally considered a difficult function, particularly when the order is dy dx. So the student will have two options, either changing the order of integration from dy dx to dx dy, which in this case is not that very likely to produce a quick result. But you can think of changing the variables x and y to u and v by means of a transformation. So we'll try to solve this problem in one of the future lectures. Now look at this problem. Limits look simple, but look at that function, y e power root x dy dx. So when you get into the job of doing this problem, you will come across certain difficulties. So there is an element of doubt whether you can handle this directly. Okay, the first integration may be simple, but after the limits are substituted, it may lead you to a very complicated final integration. Maybe this is another reason why we can think of a change of variable. So as I'm trying to explain, these are not straightforward problems. They need very special skills. How do we decide whether a change of variables is necessary? The first guideline is draw the region. You grab the domain and check if it can be expressed as an Rx region or an Ry region. So once you have heard the Rx and Ry region concept, then it's very easy to understand whether you should go for a change of variables or not. Suppose you are able to express as an Rx region or an Ry region, and if any one of them aids the process of integration, that means it allows you to integrate quickly, then we don't need any change of variables absolutely. We can execute the problem in the original variables itself. But suppose you are not able to evaluate the double integral in the Rx format or an Ry format, then you may have to think of change of variables. So this is going to be, you have to read both these things together in order to understand the context. If you are able to express as an Rx and Ry, and if the integration is possible, the job is done. Otherwise, change of variables may become necessary. Now, usually what happens in change of variables concept is the original domain will change its shape, very likely. So whenever you bring in a transformation and the shape changes, then Jacobian gets involved. So you'll understand this, but don't forget, this is a very tricky job. Changing the domain is a tricky job, but don't worry. We are here to overcome all these difficulties and to think scientifically how to take a proper decision. So the general idea is, on the left hand side, that is the region which was originally given to you. Of course, the function is not shown to you, but the region is being shown. So you can see that it's a trapezium, and integrating over trapeziums, that too when the trapezium is in a very bad orientation, is not an easy job. So using a transformation, which is hidden in this case, we have transformed that trapezium into a rectangle or a square. And look at the orientation of the rectangle. It has got its dimensions along the u and the v directions. So this rectangle is in perfect orientation compared to the trapezium on the left. So your transformation must be able to achieve this simplicity. If you are able to do that, then you have understood the concept of changing the variables. So the geometry should get simplified so that the limits become easy to fix. So now let us look at how to further understand this. On the left hand side is your original problem, double integral f of x by dA over the region R. We have used a transformation. The variables x and y go out and the new variables u and v come in. And then the region also is changed. Therefore, the dA is no more dA, it is dA prime. And the region R is now a new region R prime. So right hand side is the new integral that we have created out of the left using a suitable transformation. So if that is the case, look at the right hand side. The dA prime is being written as mod j du dv, where j is the Jacobian. I told you already that whenever there is a change of variables, that means change of coordinate systems, it is often accompanied by the Jacobian. Why we use a mod for j is very important, because you know dx dy is the area element dA, and area cannot be a negative quantity. You must have noticed from your previous classes that the Jacobian sometimes can return negative values. So how can the right hand side be negative? So that's the reason we take a mod j. So mod j du dv together constitutes dA dash. dA is dx dy on the left, whereas mod j du dv happens to be the expression for dA dash or dA prime. So that is about when you should change the variables. What next? What do I do from here? So with this, I have exhausted all the techniques of double integration, at least the ideas. But unless we get into some serious problem solving, we'll not be able to get a complete view. So we will be interested in exploring how double integral is being applied in other areas of science and engineering. For example, where does it occur in civil and mechanical engineering? Or where does it appear in, let us say, computational biology and things like that? So there's practically a very big scope for the double integral to be applied. But whatever is possible within the means of this lecture series, I'll try to present them before you. So dear friends, I hope you have understood this part of the lecture, and let us meet quickly for the extension of this. Thank you very much.